Testing. Okay, so today we're going to experiment with some alternate romaji coding methods, alternate input codes, and currently it's pretty conventional for the most part. However, some of the more obscure characters have unusual codes like these in order to allow like kanji to be more easily inputted. So now, when I ran Kana stats on a bunch of random texts that I just grabbed on the internet, I noticed some interesting stuff. Let's sort based on number on the second column, which is this one right here. This one and the second one, or the first column of numbers is we'll sort by that one, and we'll see that the characters that appear most commonly are start at no and ta and ni, ha, shi, wo, to, te, na, I, ru, re. So I want to experiment with making these characters just one key to input, and the vowels, what you would call agyo, a, I, u, e, o, a, I, u, e, o. These ones will just be uh, a little bit more difficult to input, like with semicolon A, semicolon I, semicolon U, like that. And we'll just see how that works for now. Well, what I'll do is I'll try and run the last rank contain command, which assigns kanji to all of these to like each key. At least it picks codes for as far as the first character is concerned for the most common kanji, and then we'll see if the kanji that it covers, which is going to be less than the current amount, which is about 1250, we'll see if that is acceptable as far as difficulty to type in characters. So, all right, now the what we have here, I'm not sure if I want to use W as the single character because W is pretty useful in typing some things like this. And this character has to be available for Unicode, for katakana, and that means that we can't just we also need to reserve the uppercase version of that character. So if we did W, then Y would have to be assigned a semicolon W or something like that, which would be easy. But then we have to figure out what to do for these for katakana. So there's we, we, wa, these ones, and so yeah, I think that what I'll do is I'll just forego assigning W. The thing is, we've chosen like the most common 10 kana or so, and we probably won't want to do all of them. I'm just going to assign them for sake of just in order to have a comparison point, just to show that, oh, if we assign too many, then we know that we've assigned too much. Just to make sure that my understanding is right, that probably we want to have about 6 or 7 kana characters to only have one key for input. Because currently we have 7, which is the vowels agyo, e, a, I, u, e, o, and then the small tsu, and the ng character here. And if you notice, ng is quite high up, so it's not really all that common as you'd expect, assuming that you exclude the readings for kanji. And e is a relatively common vowel, but the other vowels are not so common. So u is relatively high up there. E, and then a and o, and a and o are high up there. Which one did I forget? A, I, U. Yeah, U. I got all of them. U is right. Where did U go? U is, I guess, higher up. Let's see if I can find it. U. Let's do this. 2177. Okay, U is over here. So it's around A. It's pretty close to A. And anyway, so what we'll do is we won't assign W or X. X seems to be X is used for like uncommon. Uh, X is used for uncommon and obscure kana, or at least kana that are typed out of place, like the second character in kya, which is usually typed with some character before it. That's available with XX something, XX7 in this case. So anyway, X has a certain utility in that it groups together all of the somewhat rare kana or relatively unused alone kana. And then the semicolon is more like in this new system will be for common kana, but we don't really want to pick an extra letter for it. We only want to pick one letter for it, and but we still want to have it be two characters for to input. So by the way, there's a mistake that I made last time. I was constantly giving you this last column over here in the kind of stats was supposed to add up to 75%, but I was making it 25%. 75% means that out of all the kana and kanji in the ideal piece of text or most readable piece of text, the kana should represent this much of the characters, and 25 is not correct. It's actually 75, so I got mixed up there. So that's important because that helps us choose the cutoff point for how many kana we want to include in in one key codes. So also, I made a bit of a mistake here when I was trying to see if one was less than another. I was checking for less than one. And this is actually fine because none of these two would ever be equal to each other. We're sorting kana in in this system. So yeah, that just means that it's a little bit unintuitive because people don't usually see less than one here. They would usually see less than or equal to zero. That's more idiomatic, I would say. So anyway, I replace it with less than zero, which is more close in line to how people's mental model probably works because we don't want to we're checking if something is less than, not less than or equal, and even though less than or equal is basically the same, I mean essentially, because all the kana should be unique. Actually, some of them are not, but that's okay. That works fine too. It just means we'll sort things kind of differently. It's okay if some of them are the same because the binary search will always choose the same one. So yeah, now I'm going to add some options to, or let's amend this, right? And I'll change this to not say work in progress anymore. Git amend. All right. Kind of stats commands. Okay. Now let's call this master. And oh, work. Yeah, my heuristics to choose the base of this log is kind of wacky. It should just choose the upstream merge base or the upstream branch rather, but it kind of does something weird. It considers master to have special meaning, which it shouldn't. So anyway, that'll be fixed later. So I just find this much more exciting, so I'm not doing it. Okay. Now we're going to add some stuff to romaji.h, which is the new options we are going to add. Now, so we'll have we're going to be able to redefine wa, or will we actually? Maybe we don't need to because we're just saying we don't want to reassign w. I'm not sure why I picked this. I think that when I was writing notes, I wasn't sure what I would do. So I don't think we want to do wa. We want to do no code. And So by the way, I'm choosing the characters from here, from the bottom up. And in fact, we can just type in a bunch of them here. Let's say no ta. Let's actually delete all these. And ni ha shi. And wo is handled differently. We have this right here to give it a single letter code. And we have shi, to code, and te, and na, and e. So e actually is both a vowel and it's relatively common. So we'll just have e keep its code, keep its input code for now, just regardless of the configuration. So now we have char do code and char re code. And we also have small to code. Now we want to be able to find different codes for a, I, U, E, and O. And oh, we actually didn't do char and code, right? And we also want to say char a prefix char, right? And this lets this, if it's non-zero, the idea is that it will set a to some other value, or rather, if this is non-zero, then rather than have a be just a single, this character be just a single key, it'll be prefixed by some other key. So we'll have that for a, and not for e. We agree that e is always going to be the same code, so we'll do u prefix char e prefix char o prefix char. Now I consider just having the user pass in these like as just a list of arbitrary codes, and that probably that's somehow part of me tells me that makes more sense just to have a map of like hard coded codes. But that seems like it's not going to interact very well with the flag system of like the user typing in some flags and then we set them unless we want to like search through the entire list and then apply it. But the thing is, this list is always going to be pretty short, right? It's never going to be more than like 200 entries or so, I suppose. So perhaps we do want to go with a system of like of just having some hard-coded codes. But so I'm not sure if I want to change my plan, because I was worried about basically I was worried about the idea of creating a function which did like void change config, and it would take a char of some code and char of some new code, right? I was afraid of order of n complexity of searching through the existing code array, and a hash map just doesn't seem all that much better. Yeah, I think that this is probably what I have here already is this the simplest way to go, and I might change my mind later, but for now I don't feel like micro optimizing the readability or the maintainability, because I'll just fix it later once it becomes obvious what the right thing to do is. Okay, so now one thing we need to do is we need to maybe we should say like a romaji test. How many do we have already? Oops, edit romaji test. So we could just add some new stuff in here. We can do like special. We can add some tests for like special codes here. Like this, start test file. By the way, when we go to romaji.c, oops, do we sort the codes after we've added them? So we don't. I think maybe we want to sort them so that this is more testable. Yeah. So what we can do, oh, I never amended, oops. Let's do HGA kana stats util and kana stats.c. And okay, still have these. So, all right. Maybe we should go with the test-driven development because I'm just kind of drawing a blank as to how I want to handle this. So we'll do special null code. Yeah, but I guess I don't really like this. Let's see here. Okay, let's just take what we've written so far and put this in a separate file. I think I do want to actually write just sort these romaji codes for increased testability. So we'll do tem tilde slash new romaji flags. We'll just paste these here. Okay. Now let's go to romaji.c. We're just going to sort and then fix all the broken tests. And we'll sort by, what are we going to sort by? I guess we'll sort by, we'll sort by the input code. That seems to make the most sense because the kana might be redundant, might have duplicates. So we'll do sort. Oh, you know what? You know what I wanted to do. That's even more. That's also pretty important. Is check for overlapping codes. So essentially, if something starts with like some key X, there should be no other codes that have X that start with X and then have some other characters after them. So what we can do is we would probably want to sort them and then give an error about something having let's see here. So when we initialize the romaji, we have this logic. So okay, romaji. Yeah. So let's have a test to check for duplicates. Start test file. Do not allow duplicate input codes. All right. And test, and we hope that we get a non-zero. Should we print out the error to standard error? Maybe we should. Because I like really this is a fatal error, but I want to test it as well. And so what we could do is we can have a function which is like check for duplicate codes. Yeah, I'm not sure how I want to handle this. So we'll say romaji. You can call this int init romaji, and we'll have a romaji.h. We'll also have a init romaji or die. Inline void init romaji or die. I don't know if I really want inline. I don't really see what the point of that is. Let's just have it be in the C file. Init romaji and void init romaji or die. Oh, okay. And let's say config if init romaji config, then we can say die found duplicate input codes. I guess we want to do this. Turn 1 for success. Otherwise, we'll do a here. Let's return 0. So basically, there's going to be no, or we'll return 1, regardless. So there's going to be no change in behavior here. And we'll also find all usage of init romaji and change it to init romaji or die. Init romaji config init romaji. Okay. Okay, this might take a while. Edit free kanji keys. Call it 26. Or we want the romaji to die to be, maybe we don't want to change the name. We'll say void, let's see, int init romaji and return error. Right, and here init romaji and return status. There. So 1 for success, and then we have init romaji or die and return status. There. Okay. Now I don't have to rewrite so much stuff. Romaji int init romaji and return status. Okay. Here we if init romaji and return status fails, aborts or dies. Return 1 for success, 0 for failure. Okay. Now we do not allow duplicate input codes, so we do char. Let's see. We're going to have to reinitialize. So romaji test. Okay, so this is more like a internal test. Let's do init. Let's have struct romaji config equals that, and actually we can probably just use a designated initializer to set this up. So we can oh, there's no way for an error yet because we haven't allowed the user to the caller to specify arbitrary. Oh no, we can do it here. Here, hiragana woki. So we'll do what we'll do is we will look for hiragana woki. Hiragana. Okay. Hiragana key equals k. Obviously, other codes will start with k. So we'll do xfprintf error status, and then init romaji return status. Okay. There we go. Let's add the \n. I don't know if I want to add it or not. Let's not. So, right. Now we can do start test file init returns 1 on success. Okay. So we're checking the positive case. This actually should be 0 for failure. And here we have and test status 1. Okay. Okay. So now we're going to do a we will look for any character that starts with romaji hiragana woki. So that we're going to do a simple implementation first, or an idiotic implementation, I guess. Int I. Okay, we already have an I. If so, for I 0, I is less than, what is it? We have, what is the romaji I dot append mapping, what do we have here? Config, what do we call the config, or rather the array of keys? We have, I'm trying to look for a declaration of an array somewhere. No, not here. Key mapping array, codes. Oh, I see. Okay. Codes dot L and our size I plus plus. Say if codes dot L I 0 is equal to k, then we return 0, found duplicate. Check for duplicates. And we can't move this down because we're sorting. We're not sorting, rather. So what we'll do, I guess, is if codes L.I, it's like okay, and yeah, I'm not sure how I want to handle this. Stir CMP. So the thing is, with this commit, it's going to be very simple just to start checking for duplicates. And so I don't want to have test-driven development hacks in the commit. But the thing is, the commit only really has to do this one thing. So I'm not sure how to handle that. Let's just finish writing this. Commit is not codes dot li dot conv. This should be orig. Right. Duplicates. Okay. Now that should work. Romaji test. Die. Okay. We don't have a die, right? Or we don't have the everything here. There. Okay. Count. It's not size, but count. Or is it CNT? I don't know. I think it's CNT. Error. What happened here? 592. Found duplicate codes. How did that happen? Oh, I don't want a K. I want to look for equals config dash hiragana wo key. There. Okay, that works. So what I guess we need to do is we need to are there any other ways to include duplicates? So we could have that overlap with well, let's look for other ways for it to overlap, because we can probably do it with include va. So, or no, this is xxj. Okay. All right. Start test. Let's just try another way. Do not allow duplicate codes to test. That is 0. Okay. Right, hiragana woki. And let's see here. Include kanji numerals. So I'm not sure if I can think of any other way for it to overlap. Like I'm thinking that maybe we can cause some other config option to get to overlap with hiragana woki, and then it would be dependent on other config options, which is good. But I don't seem to find anything like that, any opportunities like that. So, and really, this actually is not generally test-driven development because I could have made this check even simpler by just checking other kana prefixes. So, I'm not sure how I feel about that. So, do not allow. Let's see, overlap with one will key. Okay. 2. We can just do it again. Let's just do it again. And we'll do it again, just for good measure. And let's do make romaji test. Okay. So, and if we can make all the tests, oh no, some of the tests are not passing. Digit hira count. What happened here? Less kana stats util test.c.8 digit hira count. Huh. Okay, let's just run these tests one by one to get more easy output. Okay, cool. All right, I didn't actually update the tests for the new output, so we'll do okay. So let's commit this, and we'll just say error checking in romaji initialization. Right, and now we'll fix the kind of stats command thing. Okay, here. So it's the empty input. Okay, we want to fix that. And make again. And now we have one char. Okay, let's see what this. Let's see what went wrong here. Okay, everything. So fix that. By the way, new sort. If it's empty, okay, it still outputs the goal K line. I was worried a little bit about that one. Okay, let's just keep updating the tests and checking that the new percentage is correct. It has been applied correctly. No other changes have happened. All right. And after I update everything, I will check the git. I'll check the diff and make sure that nothing else has changed. Mix 2 chars. Well, there's quite a lot. Okay. Katakana. I wonder if I can just do regular make. No, that's giving me too much output, so I don't have access to the copy line. All right. Hiragana mo. Kanji. All right. Hiragana I. It would be nice to make the test framework support like not crashing when there's a non-fatal error found. Okay. Chong Kigo. This is we're getting to the end. And Chong Kigo with others. and va, really getting there, and wagyo, and 8-digit, and hira count, fraction. What is that? Hira count fraction. I don't remember what that test does. Oh, it has a fractional number in the decimal place. That's what it's for. Round up the right column. Okay. And so now we're getting in a different test case, so that's why things seem to be a little bit different. 12-digit kata count and 12-digit hiragana count and 12-digit hira and kata count. Okay, good. So now I'm sure that we'll find that, oh, this is no longer doing a roundup check, is it? That is annoying. So I have to fix that. Okay. Kind of stats. So the rounding tests are going to have to be fixed, I guess. So I'm going to look for anything that has a unusual wagyu with ducting, okay? So what I can do is add more kana in that one. Let's see. Hira count fraction, right column, round up right column. Yeah, that's no longer gonna do it. Okay, so we're gonna have to fix a few tests. Edit kana stats util test, and we have round up right column, hira count fraction, 8-digit. So I guess we mostly want to focus on this test case. Let's just double check this one. 12-digit hira and kata count. So okay, so that's not really a fraction thing. I don't think we have to worry about that. And if I multiply this by 3, it does look like it's getting similar numbers, because basically we're tripling what we had before. So 6, 2 6s become 8, and then plus 1, that makes sense. And then you add 21 to 1. 21, 8. Okay, that seems about right. Now, okay, round up right column. So this is definitely going to be round up right column. Okay, now we have 42 out of 87. So what I'll do is I'll open up a browser and we'll do 42 divided by 87 and times 3 divided by 4. Okay, right column, round up right column. Okay, this is now 36, so 3620690, 3620689. Okay, so we're still rounding up. We're still doing a roundup check. That is nice. Hira count fraction is 42 divided by 85. Did we do other roundup checks? Round up. Hira count fraction. I maybe in the other test case we did. Times 3 divided by 4. 37058. Round up right column. Hira count fraction. 37.05882. Okay. 8-digit kata count. Okay, we just checked that. That one seems fine. And 12-digit hira and kata count. And okay, wagyu with ducting. So that's checking round down, and I do think I would like to check the round down kind of explicitly. Chonkigo with others. Um, let's fix Chonkigo with others. Kana stats test. That's checking rounding up, but I do kind of want to keep that. So Chonkigo with others. Okay, edit test input. Kana stats test. Chonkigo with others. Kana. Oh, dot c dot Chonkigo with others. Right. So right now it is evenly like 5000. Let's give it other stuff to compete with, other characters, and that way ka ki ku ke ko. Right. Let's see what happens if we do that. Make one kana stats test. Let's see what happens there. Okay. Somewhat more chaotic numbers. So we have 9 characters total that are katakana and 8 that are hiragana. So, okay. We have 8. Okay. Well, I don't know if this is rounding down or not. But we're going to round down in a different place. Let's just make sure the values are correct. Let's see. So we have 9 katakana, 17 characters total, and we have 6 of these chonkigo, 352941. 352941. Okay, now times 3 divided by 4. 26.4705. Okay, this is rounding up, and I think this was rounding down. 35.2941. Yeah, that rounds down. Okay. I'm happy with that, I guess. Let's didn't mean to add a bookmark. Remove. Okay. So yeah, let's copy that in place. And I don't think the other one I was disappointed because it did no longer check rounding down, but we just verified we're checking rounding down now. So just check that these tests are not hiragana mixed, hiragana fractional, percent fractional. Let's see if this still is. No, this one was not true anymore, was it? Less fractional. Okay. Katakana percent is fractional. Okay, that's still true. And let me check the word fraction in any other. All right, hita count fractional. Let's see here. That's hita count fraction. Okay. Still true. Hiragana count still has a fractional value in the decimal place. Or non-zero in the decimal place. Okay, I don't think that we have to update any others. Okay. Now we'll do git fix up on H2. All right. Now, other errors we can check for in the romaji initialization is we can check for not using a letter that can be capitalized. Let's see. I might be getting ahead of myself. Romaji.h. So hiragana woki does not have to be capitalized here. We don't want to capitalize it, right? So I'm thinking that that in the next step, when we enable specifying arbitrary codes, we need to make sure that the keys can be capitalized in order to get the katakana equivalent. But for this one, we're not interested in capitalizing for the katakana equivalent, really. That's not what this field is for. So, oopsie. Okay. So here we have this. Don't allow overlap with one wool key. Okay. So tests all pass. Good. So next, I guess what I want to do is actually make. Let's see. Well, I saved that file in my home directory. What did I save it as? I saved it as let's see here. Hold on a second. I'm going to pause the video. I saved it as new romaji flags. Okay. So let's edit new romaji flags. Great. So now we want to now I think that there's probably other simplifications we need to do. So why don't we go here and we'll say, I think what we want to do is we want to put all these things, all these like hard-coded stuff inside of the inside of the initialization thing. We don't want to make it data driven anymore, at least not have a static array like this. We want to have just add it manually because we're going to have ifs to add and remove stuff anyway. So what I think I'll do is before I do that, I guess I'll make these things kind of configurable. So does J and V, do they allow overlapping? Can they overlap with anything? I think maybe not. J, V, oops, V. Okay, they don't. So, let's start to sort this stuff in romaji.c. I think that's going to be the easiest way to handle this. So we're going to do I'm going to do a qsort edit util.h. So we want to do a sorting so that we can start testing these a little bit more easily, because I'm going to move stuff around a lot and I don't want to get into any trouble. Elements is codes.l, count is codes.count, and less than is string compare codes a dot, let's see here, a dot orig and codes b dot orig is less than 0. Okay. And we will probably want to add this we'll add a I want to die if it's ever equal to 0, because that means something is equivalent. So we'll do an int. Yeah, I'm not sure if that's a good idea though, because we want to return an error if that happens, right? So what happens if they get two codes that are exactly equal to each other? Yeah, so we don't really need to. Let's just sort it this way. I was thinking about doing error checking on the fly, but I don't think that's going to work out. Sort codes dot count and count. Try again. Oh, not count, but elements. L. Okay. And that worked. That's a little surprising. edit romaji test.c. That doesn't make any sense. Codes.l. Oh, because we sort it when we get them. No, we don't sort it down here. So how is that even possible? I guess we have it. Oh, we sort it in the. We sort it somewhere else. Kana stats. So we do romaji test. I guess we sort it elsewhere. We sort it in make map.c. Okay, I remember now making this decision before about where we want to actually sort it. And we do allow you to sort. Yeah. We're gonna have to start sorting anyway. Let's go ahead and so we're gonna have to start sorting anyway because we do need to do checking for duplicates in more complicated scenarios. So here, because I know we're gonna check for duplicates at a different time after the sort, eventually we'll do that. So let it romaji test, and we'll do generate map test file. So maybe we really don't need to sort because we're starting to write the test right now. And we don't have any tests to fix. So, okay, yeah. And so the tests that already exist are sorting later on. So we don't have to sort now, right? We can just kind of, we can sort when we have to start checking for duplicates. So new romaji flags there. Okay. Okay, next. So there's nothing else to do that I can think of now. We want to. Uh, Okay, I've decided that what I'll do first is I will make the small to code and encode customizable. And at that point, what will be possible is we can then allow these to exist, these things as actual options, because these start with J and F, and I don't really want to just drop them because I do want this to be configurable by other people that use it. But the thing is, they overlap with these two. So first, I'm going to start off by making the small to and customizable. And in order to do that, we're going to have to make this a bit more flexible when we append mapping. So here, as you can see, we're appending mappings, but we also want to be able to say, append or add the katakana as well. So in other words, we have like an extra flag which just says add the katakana version of it. Now, what we'll do is we're going to get rid of this extra flag here, which is use as is, and this is just going to always be it's always going to be true, and we'll have auto katakana as a flag, and this will be false for katakana, things that are already katakana and things that just don't make sense as converting. So let's get rid of use as is, and we can just get rid of all the ones that are already equal to 1. Okay. All right, but I think what we need to do first is start to sort. I think that is probably what we need to do first. The reason is because we are going to start moving stuff around. So let's open up new romaji flags again. So yes, we are after all going to sort. So to init romaji, okay, romaji config. All right, here. do start test. Let's check. Let's check sort all codes. Check sorts all codes. So we're going to turn on every single customizable thing and make sure that we sort it. Sort everything. Okay. Now we're going to have a int I do for I is 0, I is less than, oh, we need to actually grab them. We need to actually grab the get, what is it called? Get romaji codes, get, yeah. So we have struct key mapping array codes is 0 and init romaji config and get romaji codes just of codes. Yes. Okay, I is less than codes dot count and I plus plus. Probably don't need that. Okay. Now we're going to print the code and we'll just say this converts to this. Yes, and codes.element I.orig and codes.element I.convert. Out. Okay. Then we can do destroy array. Okay. Codes config. Right. Now we'll say dot hiragana oki. Hiragana. Oh, oops. Hiragana oki is that. There. And dot, what else? Dot include kanji numerals is on. And dot classic wo is on. And dot include va is on. And dot wa gyodaktang is on. Okay. Let's try that. We never end the test. End test with expected. It's not there. With content in file. End test content. What's it called? Test.h. Test util.h. End test expected content in file. Content in file. Okay. Okay. Check to see if the test output looks correct. Okay. Okay, everything looks fine. So and we'll say sort all kana for increased testability in coming changes. Okay. Then edit romaji.c. Now, yeah, let's get rid of this use as is thing. We don't need it anymore. And get rid of that. So I guess I'm not sure if that's the right order I want to do it in. That's fine. We can do it for now. Let's go to append mapping, and we'll say int auto kata kana, right? So here. Zero, one. Don't do it for that. Don't do it for this. Say cannot use auto katakana because hiragana version uses combining code points for dakuten. All right. Okay. Great. So we don't do it for these. Let's say we don't want to use the combining diacritic for this. I guess we could. Doesn't make sense that we don't do it, to be honest, but I don't want to go and start fixing that at the moment. So we'll do append mapping. Use as is. Okay. So let's auto katakana. How are we going to do this? Let's copy this and paste it in here. So if not auto katakana, then oopsie, not auto katakana, then we can return early. Okay. Don't need that. Don't need that. Don't need that. Okay. Append mapping. I see. So here we'll do grow array by codes 1. Okay, then we copy the new things into place. We'll do append mapping orig conv and 0. So we're going to call ourselves, but without appending it automatically. So then we say if auto katakana, then we return. We're done. Otherwise, we add this. Okay. Otherwise. Okay, so the purpose of append mapping here is to just grow ourselves and create something that we can convert in momentarily. So yeah, this is a little bit funny looking, honestly. Orig is that to char romaji char. Let's call it R. Okay, then down here, there we go. Append mapping. Okay, so append mapping should work now. And we'll do append mapping of this. Here, got it, kind of. Okay. Do romaji I dot auto katakana. Okay. Okay. Okay, let's see if that works. Okay, no, because we have a bunch of things we have to declare differently now. Okay. So let's take these and here, I'll just copy and paste them down here. So can't H to K. Right. Seem to work. Romaji. Oh no, it's interspersing the input with the output. So res 10. Okay. Now we can say read / temp results in there. Okay. Good. Okay. That's 7 items. Get rid of 7 more and 3 more. Right. And there. Now we got to do it a little bit more for these. 0 here. Slash in. Right. Cat / temp / in into sort HK. All right. And those go down. Where did I just put them? I guess they go here. PW. All right. These get to be 0 and 0. We don't use auto katakana anymore. Those are 0. Those are 0. Right. Right. And do okay. Oh. Got to be careful. I'm losing the tab spacing. Okay. Okay, can delete a whole lot more. Right. We have this. And lots more that we need to fix. Okay. Let's fix all of these. Get rid of these. And we'll do new sort this. New sort into temp out. Okay. Read temp out. Okay. These we don't want to delete the 0. We want to delete the 1. All right. Okay. Oh, but we didn't capitalize it too. That's a problem. There we go. just do all these at once. Okay. And we may as well put all these katakana in one spot because we are changing all these lines anyway, so the diff is definitely not going to be very clean. Let's just move them all at once. That way we don't have to do so many separate runs of that external tool. Okay. Oh my gosh, there's a lot. And they're all interspersed with the normal ones. Let's do, okay. So we'll do grep for, let's pull out the things we want. Let's pull out the lines we want to change. So it will be tab followed by a 0 and a comma in romaji.c. Okay. Right. So it looks like those are all together. Now? Okay. Then we will put these in a fix me file here. Right? And then we're going to get the reverse of that, v, which will be all the lines we want to keep. And we'll say put these in since this keep me, right? Then we'll move keep me to romaji.c. Right. Okay. Then we'll do new sort katakana conversion using the temp fix me stuff. Okay. Then we as temp keep it in fixed, and we will write it here. Temp fixed. Okay. But they're not really fixed. We don't want these ones. Nor do we want lowercase letters. Okay. All right. Good. So now the rest we can just remove the one. This can be up here. Actually, let's just keep it down there because I don't have a better place for it. And then these just need the one, they don't need two ones. Right. Okay. Let's see if that passes. No. Sorts all codes. We have some difference. Let's see what it is. Yes. Sorts all codes. I thought I fixed that. I thought I actually created that file. What happened? All right. I guess I just checked to see if the file looked right, but I didn't actually put it in place. Okay, but the existing test passed, which means the make map test pass. So I don't think that we have anything to worry about. Now, what we should probably do is actually change this so that it uses, it just calls the append map function directly. I'm not sure if we really want to put it in this table, but I mean, it could go either way for now, but we do know that we need to start pulling things out of here. But in any case, I think that for today we'll just we'll take a break and call it a day, and I will try this again later maybe tomorrow, maybe not. And in any case, so far we have started renovating the romaji module, and we're going to make it parameterizable soon, more parameterizable soon. And we've kind of cleaned up the way this is defined here. We don't need to have that extra flag, which does make this more which makes this module more complex and harder to mess around with. We added a test for sorting that checks the mapping is sorted without having to bring it in, like create the full kanji map or call any external commands to actually make it sorted. Because before now, in order to actually see the sorted results, you had to call make map, I think. Yeah. But now we don't have to do that. We just have to call this one function. And we have this to check for duplicates. That's going to get more generalized soon. But for now, it's not. Anyway, this is a bit of a mess. I'm not sure if I'm happy with calling recursing like this. It's a little bit non-intuitive. I mean, we could do this in a loop, or we could do like static void append. I guess we do kind of need append mapping as a raw, like append mapping, append raw mapping, char const orig, char const conv. Append mapping. One, two, three. Append raw mapping. Okay. Append mapping, append raw mapping. But then append mapping, yeah. Append auto kind of mapping. I don't know how I want to do it. This is a little bit better than recursing this on itself. This is better. Now it's just funny that if you pass 0 here, it's going to just call append raw mapping alone. But the thing is, we do want to kind of have this this parameterized version of it. But we're not going to do that forever, right? So maybe let's fix this. We'll say append mapping and append auto kara mapping. There. Okay. Append mapping. Okay. Append auto katakana mapping. Right. Katakana mapping. Oh no, not for those two. In fact, we only do it for that auto katakana mapping. Okay. Right. Append mapping. There we go. Okay, so just about ready to finish up. As soon as we clean up this here, append mapping. Okay. So let's fix this up here. Append. Oopsie. Append mapping. right. I don't know if I want to fix this now. Let's go append mapping. Let's fix this down here. So if romaji I dot auto katakana, then we'll do this append auto katakana mapping. Right. Else append mapping. Ooh, only need one parenthesis. Okay. Now we can auto katakana, so 459 append auto katakana mapping. All right. Great. So anyway, so I guess we want to use this in the previous commit, right? Check sorts all codes. Check sorts all codes. We will do it. Amend using this. Right. And then we'll do a commit with is just clean up append mapping code. Right, so now we can make this, and the previous one should also be fine. Make, yes, okay. So anyway, that is all for today. Check out work. So next time we will not. What are we going to do? We are going to fix. We're going to increase parameterization of the romaji module so that we can basically do this. Edit new romaji flags. We basically want to add these parameters so that very common kana can just be typed with a single key. And then we're going to run some measurements to see how that actually works out in practice, or how, rather, what the frequency of what the mapping looks like. I can't say exactly what I'm going to check, but we're going to make the map with these codes and see how that works out. So that's all for today. Thank you for watching.